Hello. In this worked example video, I'll be going over a calculation related to the learning outcome. Describe waves in terms of their wavelength, amplitude, frequency, speed, and intensity. This question specifically deals with amplitude and intensity in their relationship. Remember that intensity is proportional to amplitude squared. The question, which comes from ACE Physics Syllabus Code 9702, Paper 12 from May-June 2014, question number 23, reads, a sound wave consists of a series of moving pressure variations from the normal constant air pressure. The graph shows these pressure variations for two waves at one instant in time. So the pressure variation measured in hundredths of pascals against distance measured in meters here. It says wave 1 has an intensity of 1.6 times 10 to the negative 6 watts per square meter. What is the intensity of wave 2? Because we can read off the graph the amplitude for each wave, and we're given the intensity of one of the waves, that's enough information to be able to solve this. And so here's how you would go about the calculation. Because I want to know the intensity of wave 2, I'm going to kind of make that my subject here. And I'm going to set up a proportion. The intensity of wave 2 compared to the intensity of wave 1, because I know its intensity. Because the intensity is proportional to amplitude squared, I can set up a ratio like this and solve it with a proportion. So the intensity of wave 2 is proportional to the amplitude squared of wave 2 over the amplitude of wave 1 squared. Because each of the intensities is proportional to amplitude squared, I can solve for the unknown by setting up the calculation this way. Another way to think about it is, if I wanted to turn this into an equation, there might be some constants in front of the amplitude squared, but all of those constants would cancel out, and so I'm able to just set up the calculation with what I know and solve for what I want to know. The amplitude of wave 2 is 3 times 10 to the negative 2 pascals. But because these orders of 10 and units are going to cancel, I could really just kind of read off of the y-axis this value here. And so I'll set up my calculation like the intensity of wave 2 over the intensity of wave 1. I'll just go ahead and substitute in the value now. 1.6 by 10 to the negative 6 watts per square meter is equal to the amplitude of wave 2 is 3, and the amplitude of wave 1 is 2. And each of those quantities is going to be squared. Solving for the intensity of wave 2, I've got 3 over 2 is 1.5. 1.5 squared, 2.25, and then multiplying both sides by this value, I've solved for the thing I want to know, the intensity of wave 2. So I'll show all of my working here. Multiply that side. So if I do that to that side, I've got to do the same thing to the other side. So it remains equal. And the intensity of wave 2 will be 1.5 squared, which is 2.25, times the quantity 1.6 times 10 to the negative 6, which gives me 3.6 times 10 to the negative 6, which is choice C.